And now for something completely different. So this is called a parametric function. The pair does not refer to there being a pair of functions, but it refers to the t, which is called a parameter. So just like in real life, time passes and then we can move through space. So if time was not passing, my hand would not be able to move. So there's the parameter time that underlies everything. Now I'll graph this. So of course we're going to be using the graphing calculator. And the first thing we need to do is change the mode. So go to mode, and right here, there's actually different ways that you can graph. Here's parametric. So go down, hit enter, it's now in parametric. So now when you go to y equals, it's not just going to say y equals. Hold on, I've got stuff left over from a different class. It's going to say, what does x equal? Which is 2 sine t, sine, and now when you use this key, it will use a t. And then plus 1. And the other one is 5 cosine t minus 2. Now we need to set up the window. So first of all, t. Because we're talking about a trig function, the t should go from 0 to 2 pi. Make sure it's in radians, and then go from 0 to 2 pi. Now the step, so pi divided by 24. So the TI company has set this to be pi divided by 24, but you can change that if you want to. I'm going to show you in just a second what happens if you change it. And then x. So let's see, x could be 2 plus 1, it could go to 3. And y could go 5 plus 2 or 5 minus 2. It could go to 7. So I'm just going to go negative 7 to 7 and negative 7 to 7. And then take a look at the graph. So it looks like an oval or an ellipse. Okay, so one thing was graph it. So that's just sketching a graph. And in English, we call it an oval, but in math, we call it an ellipse. Now, I want to go back and show you what happens if you change the t step. So basically, this controls how fast and how accurate it graphs. So if you make this a small number, like 0.01, then it's going to graph very slowly and very accurately. Okay, I'm tired of waiting, so I press on and that will stop it. Now change the window. And what if you say, well, I want you to speed up, so put the step at 1. So then it's going to graph it faster. Well, it graphed it really fast, but it didn't do a very good job. So that's how come TI programmed this so that as a default, it has pi over 24. So basically it's going to plug in 0, and then 1 pi over 24, 2 pi over 24, 3 pi over 24, and then that's sort of a mixture between being fast enough and being accurate enough. Okay, the next part is not with the calculator. Eliminate the parameter. So that means eliminate t. So basically to do that, what I'm going to use the identity that says sine squared plus cosine squared is equal to 1. But in order to get sine squared and cosine squared, in here I need to isolate the sign. So I'll need to first subtract 1 from both sides. And I'm going to go ahead and work on this one at the same time. I'm going to add 2 to both sides. All right. The next thing is, for this one, divide both sides by 2. And for this one, divide both sides by 5. So now I've isolated the sine and the cosine in each equation. Now go ahead and square both sides, preferably with a red pen. That makes all the difference. Then what you do is add the equations together. So on the right side, it's going to say sine squared plus cosine squared, which equals 1. On the left side, this would become x minus 1 in parentheses squared over 4. And this one would be y plus 2 in parentheses squared over 25. And then I eliminated the parameter. Now with this right here, in case you haven't had pre-calculus, you can even read where the center is. So where's the center of this ellipse? So for this, you just take the opposite number, positive 1, and that's what x equals. And for this, you take the opposite number, so it's negative 2, and that's what y equals. So that's where this center is right here. X is a positive 1, and y is a negative 2. And then, that's everything.